Deployment of AI-driven robotics in manufacturing, 2024 rollout phases and $3 billion investment allocation for U.S.-China collaboration. Overview. The deployment of AI-driven robotics in the manufacturing sector is set to experience transformative changes in 2024, driven by a collaborative investment of $3 billion between the United States and China. This initiative aims to enhance automation efficiency and innovation across various manufacturing sectors, positioning both nations to navigate global supply chain challenges and maintain technological leadership. Key developments and timeline. 2024 Initial Rollout Phase. Investment mobilization. The $3 billion investment will be allocated for the development and integration of AI-driven robotics in manufacturing facilities across the U.S. and China. This funding will target advancements in automation technologies, robotics, and AI applications aimed at improving manufacturing processes. Focus areas. The collaboration will emphasize sectors such as automotive, electronics, healthcare, and consumer goods, areas where both countries seek to enhance productivity and competitiveness. Implementation strategy. The rollout will involve joint research and development initiatives, sharing of technological expertise and pilot projects in selected manufacturing plants to test and optimize robotic applications. 2033 Projected growth and market expansion. Market forecast. The global AI market is predicted to grow significantly from approximately $184 billion in 2024 to an estimated $2.53 trillion by 2033, with a compound annual growth rate of 33.83%. This rapid growth is expected to be fueled by increased adoption of AI technologies in various sectors, including manufacturing. China's positioning. China aims to solidify its leadership in advanced industries, particularly robotics and AI. Leveraging its vast domestic market and robust government support for innovation. The initiative will also facilitate the integration of AI technologies into smart manufacturing practices. Collaboration dynamics. Investment in innovation. Bilateral cooperation. The $3 billion investment exemplifies a growing trend of technological collaboration between the U.S. and China. This partnership seeks to bridge gaps in innovation and enhance competitive advantages in the global market. Private sector involvement. Both nations recognize the critical role of the private sector in driving innovation. The initiative will encourage collaboration between government entities and private companies to leverage their respective strengths in AI technology and manufacturing expertise. Technological collaboration. Shared expertise. The collaboration will entail sharing best practices, research findings, and technological advancements in AI and robotics. Joint workshops and conferences will be organized to foster knowledge exchange between U.S. and Chinese experts. Pilot programs. Initial pilot programs will be launched in select manufacturing facilities to assess the effectiveness of AI-driven robotics in optimizing production lines, improving supply chain logistics, and reducing operational costs. Market dynamics and challenges. Increasing demand for automation. Labor costs and efficiency. Rising labor costs in both countries, coupled with the need for efficiency, are driving the demand for automation solutions in manufacturing. AI-driven robotics are seen as a key solution to address these challenges. Global supply chain resilience. The initiative aims to enhance the resilience of global supply chains, which have faced significant disruptions in recent years. By adopting AI technologies, manufacturers can optimize their operations and reduce reliance on manual labor. Competitive landscape. U.S. perspective. The U.S. is focused on maintaining its technological leadership through robust innovation ecosystems. Policymakers emphasize the need for reforms to enhance competitiveness against global rivals, particularly in advanced manufacturing. Chinese perspective. China is rapidly advancing its innovation capabilities with a strong emphasis on state-directed industrial policy. The country aims to leverage its large domestic market and government support to achieve scale and export its advanced technologies globally. Use cases in data. Applications in healthcare and manufacturing. Healthcare innovations. AI-driven robotics are transforming healthcare by automating diagnostics, patient care, and drug discovery processes. The collaboration will explore the integration of these technologies in healthcare manufacturing as well. Manufacturing efficiency. Use cases in manufacturing include automating assembly lines, improving quality control processes, and enhancing supply chain management through predictive analytics and machine learning algorithms. Growth statistics. Projected market share. By 2033, AI-driven solutions are expected to account for a substantial portion of the projected $2.53 trillion market value, indicating a marked increase in adoption across various sectors. Conclusion. The 2024 rollout of AI-driven robotics in manufacturing represents a pivotal moment in U.S.-China collaboration. As both nations invest heavily in advanced technologies, the competition and cooperation dynamics will shape the future landscape of global manufacturing and technological innovation. This strategic partnership has the potential to lead to significant advancements in productivity and efficiency, positioning both countries as leaders in the emerging AI economy. The path forward will require careful navigation of market dynamics, investment in innovation, and a commitment to fostering technological collaboration between the two nations. The success of this initiative will ultimately depend on the ability of both countries to adapt to changing market conditions, leverage their respective strengths, and drive the adoption of AI-driven robotics in manufacturing. This report summarizes the anticipated developments in the deployment of AI-driven robotics in manufacturing through a comprehensive analysis of the planned investment, collaboration dynamics, market trends, and potential challenges. The deployment of AI-driven robotics in manufacturing, particularly through the $3 billion investment collaboration between the U.S. and China, illustrates a complex dynamic of competition and cooperation that reveals counterintuitive insights about innovation, market strategies, and geopolitical implications. Key counterintuitive insights. 1. Investment as a collaborative tool amidst rivalry. The significant financial commitment from both countries to advance AI-driven robotics highlights a paradox wherein rivals can simultaneously collaborate. While both nations have vested interests in technological supremacy, their partnership suggests that competing in innovation does not preclude collaboration in areas deemed beneficial for economic growth. This challenges the conventional view that geopolitical tensions inevitably lead to isolationist policies. 2. China's rapid innovation versus U.S. complacency. The narrative that China is merely a follower in technology is increasingly challenged by evidence of its rapid advancements in various sectors, including robotics and AI. This counters the expectation that established powers like the U.S. maintain an unassailable lead. The rapid progress of Chinese firms, often facilitated by state support and a focus on scaling production, suggests that complacency in the U.S. could lead to significant technological losses. 3. Market dynamics and consumer welfare. The U.S. focus on consumer welfare and market efficiency may inadvertently stifle innovation in critical sectors. The perception that maintaining low prices for consumers is paramount can undermine investment in advanced technologies that require substantial upfront costs. In contrast, China's willingness to prioritize state-supported industries over short-term consumer benefits enables it to build a more robust technological infrastructure. 4. The role of scale and technological advancements. China's strategy emphasizes achieving economies of scale, which allows firms to reduce costs and reinvest in innovation. This stands in stark contrast to the U.S. approach, which often emphasizes niche markets and high-margin products. The implication here is that a focus on scale can produce a competitive edge that is not solely about innovation quality but also about production capacity and cost-effectiveness. 5. Long-term versus short-term planning. The Chinese government's long-term strategies for technological advancement starkly contrast with the often reactive and short-term focus of U.S. policy. While U.S. firms may prioritize immediate returns on investment and shareholder value, Chinese policies are designed to cultivate sectors over decades, which could lead to sustained competitive advantages. 6. Cultural and systemic differences in innovation. The differences in innovation ecosystems, China's top-down approach versus the U.S.'s bottom-up entrepreneurial spirit, suggest that effective innovation can emerge from diverse systems. The idea that one model is inherently superior to another overlooks how different cultural and regulatory environments can yield successful outcomes. China's focus on collective goals and state coordination contrasts with the U.S. emphasis on individualism and market-driven innovation. 7. Implications of subsidization and market access. The aggressive subsidization of industries in China creates an uneven playing field that can disadvantage foreign competitors. This challenges the idea that free markets naturally equate to fair competition. The U.S. may need to reconsider its stance on subsidies and market interventions, as the current model may not adequately prepare it for the realities of competing against a state-driven economy. 8. Technological decoupling versus interdependence. The push for technological decoupling from China among U.S. policymakers may not align with the realities of global supply chains and interdependence. The notion that the U.S. can simply isolate itself from China's technological advancements fails to recognize the complexity of global markets where collaboration and competition coexist. This could lead to strategic miscalculations if U.S. firms are cut off from beneficial partnerships and supply chains. 9. The future of AI and robotics in global markets. As AI and robotics evolve, the competition is not just about technological capabilities but also about the ability to integrate these technologies into existing systems. The expectation that one nation will dominate the AI landscape overlooks the possibility that multiple players can thrive by adopting different strategies that cater to specific market needs. 10. A shift in global economic power. The potential for China to emerge as a dominant player in global innovation shifts the traditional understanding of economic power dynamics. Rather than viewing economic competition as a zero-sum game, it is essential to recognize that technological leadership can redistribute power and influence in ways that challenge existing hierarchies. Conclusion. The deployment of AI-driven robotics in manufacturing supported by the $3 billion U.S. China investment underscores a transformative period in global innovation. The counterintuitive insights derived from this collaboration challenge established notions about competition, cooperation, and the nature of technological advancement, suggesting that the future of global manufacturing will be shaped by a complex interplay of strategies, market dynamics, and geopolitical considerations. As both nations navigate this landscape, the outcomes will not only define their respective economic futures but also the broader trajectory of global technological leadership. The report on the deployment of AI-driven robotics in manufacturing, particularly focusing on the $3 billion investment allocation for collaboration between the U.S. and China, reveals several critical insights that are often overlooked but hold significant implications for the future of global manufacturing and competitiveness. Here are some of the key content points that deserve closer examination, along with their implications. 1. Investment allocation and strategic focus. The report indicates that the $3 billion investment is not just a financial commitment but a strategic maneuver to bolster both nations' technological capabilities in manufacturing. The significance of this investment lies in its dual purpose: enhancing competitiveness while fostering collaboration amidst political tensions. By pooling resources, both countries can accelerate advancements in AI and robotics, which could reshape global manufacturing standards and practices. The implications of this are profound. If successful, this partnership could set a benchmark for future collaborations in other technological sectors. 2. Projected growth of the AI market. The report forecasts the AI market's growth from $184 billion in 2024 to approximately $2.53 trillion by 2033, representing a compound annual growth rate (CAGR) of 33.83%. While many might focus on the staggering dollar amounts, the underlying trend is more significant. This explosive growth indicates a paradigm shift in how industries will operate. With automation becoming ubiquitous, firms that adapt quickly stand to gain a competitive edge, while those that delay may find themselves obsolete. The report subtly underscores the urgency for businesses and policymakers to invest in workforce development and infrastructure to support this transformation. 3. Role of government and private sector collaboration. An often overlooked aspect of the report is the emphasis on government and private sector collaboration in fostering innovation. The U.S. model traditionally leans towards private sector-led innovation, while China's model involves state-directed initiatives. The report suggests that the U.S. may need to rethink its approach to innovation by adopting certain elements of China's model, specifically in terms of strategic partnerships and funding. This could lead to a more robust innovation ecosystem in the U.S., allowing it to compete more effectively with China. The significance here lies in the potential shift in U.S. policy towards a more collaborative framework, which could reshape the landscape of technological innovation. 4. Technological collaboration despite tensions. The report highlights the importance of U.S.-China collaboration in high-tech sectors despite the ongoing political and economic tensions. This is significant because it reflects a pragmatic recognition that global challenges such as supply chain disruptions and technological advancements necessitate cooperation. By fostering collaboration, both nations can mitigate risks associated with unilateral technological advancements and address global challenges more effectively. The underlying message is that competition does not preclude collaboration, and this dual approach could lead to more sustainable technological progress. 5. Impact on global supply chains. The deployment of AI-driven robotics is likely to have a transformative impact on global supply chains. As manufacturers increasingly adopt automation, the nature of labor and production will shift dramatically. The report suggests that this could lead to a reduction in traditional manufacturing jobs, raising concerns about job displacement and the need for retraining initiatives. This aspect is often overshadowed by discussions of efficiency and productivity, yet it is critical for policymakers to address the social implications of such changes. The significance here lies in the need for proactive measures to manage workforce transitions, ensuring that the benefits of automation are broadly shared. 6. China's rapidly advancing innovation capabilities. The report illustrates that China is not merely catching up but is poised to become a global leader in various advanced industries, including AI and robotics. This dynamic is often underestimated, as many still view China as a laggard in innovation. However, the evidence presented indicates that China's aggressive investment in R&D and a focused industrial policy are yielding results. The implications are significant for U.S. firms that may underestimate the threat posed by Chinese competitors. Acknowledging China's capabilities is crucial for developing effective strategies to maintain a competitive edge. 7. Potential for disruptive innovations. The mention of specific industries such as healthcare and manufacturing, where AI-driven robotics are expected to have substantial impacts, highlights the potential for disruptive innovations. While many discussions center around existing technologies, the report implies that the next wave of innovation could emerge from unexpected areas driven by AI advancements. This potential for disruption underscores the need for businesses to remain agile and open to exploring new technological frontiers, as the pace of innovation could outstrip current market predictions. 8. Long-term economic implications. The report's projections indicate that the U.S. and China are not only competing for market share but are also engaged in a broader struggle for technological dominance that could have long-term economic implications. The significance of this competition is often overlooked in discussions that focus solely on immediate financial metrics. The future economic landscape could be characterized by a bifurcation of technological capabilities with implications for global governance, trade policies, and economic alliances. Understanding these long-term trends is critical for businesses and governments alike to navigate the complexities of international competition. 9. Ethical and regulatory considerations. Lastly, the report hints at the ethical and regulatory challenges that AI-driven robotics may introduce. As automation becomes more prevalent, concerns regarding data privacy, job displacement, and the ethical use of AI technologies will intensify. Policymakers must grapple with these issues, balancing innovation with the need for ethical standards and protections. The significance of this lies in the potential for regulatory frameworks to either support or hinder technological progress, making it essential for stakeholders to engage in dialogue about responsible innovation. In conclusion, the report on the deployment of AI-driven robotics in manufacturing encapsulates a range of critical insights that extend beyond mere financial projections. The interplay of investment strategies, technological advancements, and geopolitical dynamics underscores the need for a comprehensive understanding of the implications for both the U.S. and China. By recognizing and addressing these often overlooked factors, stakeholders can better navigate the complexities of the evolving global landscape, ensuring that both nations can harness the benefits of technological advancements while mitigating potential risks. 1. Investment and collaboration dynamics. The planned $3 billion investment for the rollout of AI-driven robotics in manufacturing highlights a significant collaborative effort between the U.S. and China. This investment underscores the importance of both countries in leading advancements in technology and manufacturing efficiency, aiming to enhance productivity amidst global supply chain challenges. The collaboration signals a strategic partnership that can potentially yield mutual benefits in innovation and competitiveness. 2. Technological leadership and market growth. The forecasted growth of the AI market from $184 billion in 2024 to approximately $2.53 trillion by 2033 reflects a compound annual growth rate of 33.83%. This rapid expansion is driven by advancements in machine learning and AI applications across various sectors, including manufacturing. The focus on leading in industries such as robotics, AI, and automation indicates a shift towards more efficient production processes, which both nations are keen to capitalize on for economic growth. 3. U.S.-China competitive landscape. The contrasting perspectives on technological innovation highlight the competitive landscape between the U.S. and China. While the U.S. emphasizes maintaining technological leadership through innovation ecosystems and private sector involvement, China is rapidly catching up by investing heavily in R&D and leveraging its large domestic market. This competition is critical as it affects not only bilateral relations but also the global technological landscape. 4. Challenges and future strategies. Although the collaboration and investment present opportunities, several challenges could impede progress, including data privacy concerns, a lack of skilled workforce, and the potential for geopolitical tensions to disrupt collaboration. The need for strategic policies that support innovation, address labor market dynamics, and ensure robust investment in technology is essential for both nations to navigate the complexities of this evolving landscape successfully. 1. The Manhattan Project 1942 to 1946. This was a research and development project during World War II led by the United States with the support of the United Kingdom and Canada, aimed at producing the first nuclear weapons. The project exemplified a massive governmental investment in scientific research and engineering to achieve a strategic national goal: developing atomic bombs to end the war. The collaboration involved some of the brightest minds in physics and engineering, similar to the proposed U.S.-China collaboration in AI and robotics, emphasizing rapid deployment and large-scale production in a high-stakes context. 2. Apollo Program 1961 to 1972, initiated by President John F. Kennedy. The Apollo program was a series of space missions aimed at landing humans on the Moon and ensuring U.S. leadership in space exploration during the Cold War. It required extensive federal funding, technological innovation, and collaboration across numerous sectors, including aerospace engineering and materials science. The program's success demonstrated how focused investment and strategic planning could lead to significant advancements in technology, paralleling the current emphasis on AI-driven robotics in manufacturing. 3. The European Recovery Program Marshall Plan 1948–1951. This U.S.-sponsored program aimed at aiding Western Europe in economic recovery after World War II through substantial financial assistance and investment. The Marshall Plan facilitated industrial growth, technological advancements, and increased cooperation among European countries, paving the way for the European Union. The program illustrates how targeted financial investments can drive innovation and collaboration across nations. Akin to the $3 billion investment for AI-driven robotics in manufacturing between the U.S. and China. Future outlook: AI-driven robotics in manufacturing 2024 and beyond. The deployment of AI-driven robotics in manufacturing is poised for transformative growth in the upcoming years, particularly following the anticipated $3 billion investment allocation for U.S.-China collaboration in 2024. This investment signals a pivotal moment in the evolution of manufacturing processes and industrial capabilities driven by advancements in artificial intelligence and robotics. Below are key predictions and trends expected to shape the landscape of manufacturing through 2033. 1. Accelerated adoption of AI robotics. 2024 rollout phase. The initial phase of deploying AI-driven robotics will focus on integrating advanced automation technologies across manufacturing facilities in the U.S. and China. This will include the implementation of collaborative robots, cobots, that work alongside human workers to enhance productivity and safety. By leveraging AI algorithms, these robots will be designed to adapt to various tasks and optimize workflows. 2030 projections. As the technology matures, we expect to see a significant uptick in the adoption of fully autonomous robots capable of handling complex manufacturing processes without human intervention. By 2030, it is projected that more than 50% of manufacturing plants in these regions will utilize AI-driven robotics, leading to enhanced efficiency, reduced costs, and improved product quality. 2. Economic impact and job transformation. Investment returns. The $3 billion investment is anticipated to yield substantial returns, with projections indicating that the AI market will grow from approximately $184 billion in 2024 to $2.53 trillion by 2033, reflecting a compound annual growth rate (CAGR) of 33.83%. This growth will create new economic opportunities within the manufacturing sector, driving innovation and productivity. Job evolution. While there are concerns regarding job displacement due to automation, the introduction of AI-driven robotics will also generate new roles focused on robot maintenance, programming, and oversight. By 2030, it is expected that jobs requiring advanced technical skills will increase while routine manual jobs will decline. Workers will need to adapt through reskilling initiatives to meet the demands of a more automated manufacturing environment. 3. Enhanced international collaboration. U.S.-China collaboration. Despite ongoing political tensions, the collaboration between the U.S. and China in AI and robotics signifies a strategic partnership aimed at overcoming global manufacturing challenges. This cooperation will enhance knowledge sharing and technological advancements, positioning both nations as leaders in the AI-driven economy. 2033 global landscape. By 2033, we anticipate that this collaboration will extend beyond the U.S. and China, influencing global manufacturing practices. Countries that effectively integrate AI-driven robotics will emerge as competitive players in the international arena, reshaping supply chains and production networks. 4. Innovations in robotics technology. Advancements in AI. The next decade will witness significant advancements in AI algorithms, enabling robots to perform increasingly complex tasks with greater precision and efficiency. Machine learning techniques will allow these systems to learn from their environment and optimize their operations in real time. 2030 technological breakthroughs. By 2030, we predict breakthroughs in robotics technology, including the development of versatile robots that can transition seamlessly between different manufacturing processes. This flexibility will be crucial in meeting the demands of a rapidly changing market characterized by shorter product life cycles and customized manufacturing. 5. Focus on sustainability and resilience. Sustainable manufacturing. The integration of AI-driven robotics will not only enhance productivity but also contribute to sustainable manufacturing practices. Robotics can optimize resource usage, reduce waste, and minimize energy consumption, aligning with global sustainability goals. 2033 Resilience in supply chains. As the manufacturing landscape evolves, companies will increasingly prioritize resilience in their supply chains. AI-driven robotics will play a critical role in enhancing supply chain agility, enabling manufacturers to respond swiftly to disruptions in changing market conditions. 6. Challenges and considerations. Data privacy and security. The deployment of AI-driven robotics will raise concerns regarding data privacy and security. As manufacturing processes become increasingly digitized, protecting sensitive information will be paramount. By 2030, robust cybersecurity measures will be essential to safeguard against potential threats. Regulatory frameworks. The rapid advancement of AI and robotics will necessitate the establishment of regulatory frameworks that ensure safety and ethical considerations in their deployment. Governments will need to collaborate with industry stakeholders to develop guidelines that foster innovation while addressing societal concerns. Conclusion. The future of AI-driven robotics in manufacturing is bright, with the $3 billion investment in U.S. China collaboration serving as a catalyst for innovation and productivity. By 2033, we expect to see a transformed manufacturing landscape characterized by advanced robotics, enhanced economic performance, and a focus on sustainability and resilience. However, addressing challenges related to data security, job transformation, and regulatory frameworks will be crucial for maximizing the benefits of this technological evolution. The journey ahead will require collaboration, adaptability, and a commitment to harnessing the full potential of AI-driven robotics.